Hello everyone, I'm Anushka. Today I'm solving the first internal test paper of Introduction to Data Science, and in this video we are going to solve the part D of this question paper, which is compatibility and pairing collaboration analytics. So let's start. Since this is the last part of this question paper, so it's only contain only one question, which is question number 19. So let's solve this. A student collaboration dataset contain a table. You can see the table on the screen, which has 6 columns and 4 rows, which is student, gender, skill 1, skill 2, skill 3, and skill 4, and 3 students A, B, and C. Here, skills are asymmetric, which is P equals to 1 and N equals to 0, and genders are symmetric. So we have the question subparts. Construct continuous matrix for A minus B, A minus C, and B minus C. B is compute invariant dissimilarities between pair. Question number C is compute non-invariant dissimilarities. D suggests the best and worst student collaboration pair. And E is include gender in analysis and reevaluate compatibility. So let's solve all these subparts of the question. First A. Where attribute genders is symmetric, yes, yes, and no, no, both matters. And still skills are asymmetric, so only yes, yes matters. So we create the three vectors of student A, B, C respectively. Here you can see the vectors of the student. So now we solve the question number first, which is A, construct contingent matrix. For pair A minus B, we create a continuous matrix. You can see on the screen, A is 0, 1, 1, 0 and B is 0, 1, 1, 0. Both 1Q, 2 skills same and 3 skills same. So mismatch is R S, तो वो 0 हो जाएगा. Then both O T and the 2 skills, skill 1 and skill 4. Now same for pair A to C, in which A is 0, 1, 1, 0 and C is 1, 0, 0, 1. Both 1Q is 0. A has C does not R, so 2 skills 2 and skill 3 is same. And in C has A does not C to skill 2, skill 1 and skill 4. Both OT is 0. Note matrix for B minus C is identical to AC because B has exact same skills as A. So we skip the B and C matrix. Now move to the B question. Compute invariant dissimilarities. In invariant dissimilarities for a symmetric attribute implies we should ignore negative matches like 0, 0. In collaboration, two students both lacking a skill doesn't make them compatible partner. This corresponds to the Jacquard's distance, which had formula Dij equals to R plus S upon में QRS. Now we find the distance for AB and AC by putting the values in the formula. Here we put the formula and we get the distance of AB is 0 and distance of AC is 1. Now move to the question number C. Compute non-invariant dissimilarities. Non-invariant means we count all matches include 0, 0. This measures how much their profile overlap entirely. This corresponds the simple matching coefficient SMC distance. And formula for this is R plus H upon Q plus R S plus T. Now put the values in this formula. We find the distance of AB and AC. Here you got the distance. For distances AB is 0 and distance of AC is minus is 1. So move to the next question. Question number D. Find the best and worst pair. So based on the skills analysis above, where 0 distance best match, and for best match student A and student B. The reason their distance is 0, they have identical skill sets. And the worst pair is student A and student C or B and C. Reason their distance is 1, they have completely opposite skill set where no one has a skills that the other lack it. Now question number E, include gender and re-evaluate the dataset. Now we compute the composite distance considering both skills and gender. Attribute will be A asymmetric, use Jacquard's distance calculated in part B, and B is gender symmetric nominal. If matches, example mm distance 0, if mismatch mf distance 1. So composite distance for the average skill difference and gender difference is for AB, the average is 0.5, for AC the average is 0.5, and for BC the average will be 1.0. So the reevaluation that the B and C is now strictly worst pair and AB and AC are tried for best. So we complete our question paper. Thank you.